Okay, so thank you for coming back early after lunch. This is the last session of DEEP. We're going to be having the final presentations for the different projects that you're working on. Just to recap, 6 different groups were given different projects that they chose that they're working on, and every 2 of those groups were then merged based on the relevance of their topics. And then they came up with a presentation and showing their work also on their website that they created with the Amazon Cloud earlier. For our presentations, we're going to be having a famous professor, Professor Alberto Leon-Garcia from the Department of Electrical and Computer Engineering. He has been teaching in U of T for more than 35 years now.
I just completed it 36.
36 years. And Yesterday. So he's famous for two books that he's written. One is Probability Statistics and Random Processes, and another book is Computer Communication Networks book that I've learned from, that actually millions of students around the world and thousands of universities learn from in electrical and computer engineering. He's also famous for all his contributions to network architectures, especially in future network technologies. Are you going to say anything? Okay. Okay, so let's start with the first group. You'll have 25 minutes, and then we'll leave 5 minutes for questions. Okay, and as we said, the best group is receiving. The members of each of the best group are receiving individual awards. So please do your best, and please also make sure you ask questions to the other teams. If you can come up with difficult questions that they can't answer, then you win. Okay? Wow. So you can get started.
Okay, so we'll be talking about getting rid of congestion, and specifically free-flowing roads and weekdays versus weekends. So let's start off with weekends versus weekdays. So what we think will happen when we were analyzing what we thought we'd find in the data was that in the weekdays we'll have a very high congestion rate during the morning and evening peak hours. This is usually when people are going to and from work. And we thought that we will have little to no congestion during non-peak hours, so that's the rest of the time. And for weekends, we thought we'll have a generally even rate of congestion, so it'll be stable throughout the day.
Thanks to the CP24 website, we managed to actually see if we were right in our assumptions. And so we chose randomly a couple of roads in Toronto. And once you choose random roads, of course, you may get different information, and not all of them will actually satisfy. So that was what happened with 400 northbound King Road to Highway 9. What we saw after analyzing was that on weekends, the rate was actually stable, what we were assuming, but the same thing occurred on weekdays. So you can see that the rate of congestion is, actually there is no congestion exactly, because the free flow is 80%, which means the road is not congested, is even less than congested, less than average. So what we were observing with this road didn't really satisfy us, because the rate was practically the same during weekdays and weekends. But then we also looked at QEW westbound Highway 427 to Trafalgar. On this road, what we actually saw was that during weekends, yes, the rate was stable. The road was congested by 20%. And here on the top, you can see the percentage, and here on the bottom, we can see that the actual delay was 3 minutes. And what we saw happen on weekdays was actually that the congestion did rise during the rush hours. We can see it in both percentage and minutes, so it went up to even 6 minutes delay, which can be explained by rush hours. Then there is one more point. You can see that here. Whoops. You can see that there is a sudden rise during midnight. What would you guys think would be the reason for that? We were just quite interested in what might be the reason for such a quite drastic delay. And what we found out once visiting the MTO website was that there was actually construction on the road at that time. So it was just interesting to observe. Then we did another road, which was 403 westbound Highway 401 to Winston Churchill. And here, that is what we saw. We saw that during weekends, the rate was fairly even. The reason the rate is a lot lower here is because this is night. This is 4 a.m. to way to 8 a.m. probably. So we can see that it's fairly even, but what we see on weekdays is that there are huge delays during rush hours. So they went up to 5 minutes, which is quite high. So what we were thinking is that the main problems that occur are that during weekends we have a fairly even, or actually, so to say, that the weekends show that the demand is quite even, which is good because the resources are used optimally, for example. And during weekdays, the situation is much worse. So we have a varying demand, which is a big problem in many terms.
So this is one of the flow charts we made. So the main problem, as you see, is varying demand. Varying demand can result in wasted resources and because of reliable public transit. It could be a waste of resources because varying demand means during rush hour normally there will be more people on the roads, resulting in probably building more lanes. Since we're building more lanes during normal times, the resources will be wasted since there is not that much congestion. Both of these result into congestion. Congestion can result into environmental impact since when we are congested, our vehicles aren't moving, which result in fumes that are released into the environment. And congestions can also result into accidents. Since we're congested, we can be stressed and may accidentally crash. And all these result in stress since we can't arrive on time. So solutions to this. Can any of you think of solutions? Well, what we've come up with is one, social changes, which means what we thought of was varying work hours. Varying work hours means that normally people would work from 9 to 5. So instead of from 9 to 5, some people work at 9 to 5, some people work earlier, 8 to 4, some people work later. This way we spread out the demand over a series of times, resulting in less congestion. Another solution we came up was ITS, which stands for Intelligent Transportation Services, a system. So what intelligent transportation systems means is ramp metering, which controls the amount of people coming onto the highways, which results in less congestion, enhancing public transit, which improving our system of public transit, tolls for congestion, which means when we are congested, we could charge tolls to make less people go on the road, resulting in less congestion, and better incident management. When an accident happens, we can respond to it faster, resulting in less congestion.
So another thing we came up with was a smart app. So what this would do is it would be an app that would run on your smartphone, it would be multi-platform work on iPhone, Android, Windows Phone, etc. So this would do two main things. The first, it would be a full-fledged GPS navigator, but the difference is that it would get data from sensors, and it would use that to check, okay, is this road congested, or is there less demand? If there was less demand, it'll use that road instead of a road that would is a shorter distance for you to help you go there. That way, it keeps the roads less congested, and it gets you to your destination faster. Second being, at streetlights, it would use your GPS data, and it would use that to check how many people are waiting at a certain streetlight. If it notices, say for example, there's 3 people waiting at a streetlight, it'll check to see if there's any people going on the intersection. If there aren't any people going there, it'll change the light in your favor so that you can get to your destination faster. So we noticed that there would be a few flaws with this app. First being that if people don't have the app, it won't work for them. So say Andrew doesn't have the app downloaded on his phone and he's driving down the road, but he actually goes through the intersection. The system doesn't know that Andrew has gone through there, but so it changes the light, but that isn't in favor of Andrew, that's in favor of me. And also, the app might also detect that, multiple people in one. It might not be able to detect multiple people in one car. Say all 3 of us are in one car and we're going, and we all have the app installed on our phone. It doesn't know that all 3 of us are in one car. It might think they're 3 separate cars. So that might also cause another problem.
So another thing that we have to discuss is balancing commute time. So how we thought we would do this is by splitting up the streams of commuters that are trying to use the same popular highways to get to where they're going. By splitting them up, we'll decrease the overall commute time and increase the overall commute speed of all the drivers, and we hope to achieve free flow conditions. So these are some statistics that we gathered. This is an example of a congested road here. Examples of congested roads are the 401 Highway 410 to Highway 404, and the 401 eastbound Kingston Road to Salem. This is the 401 eastbound Highway 410 to Highway 404. And we see here that around 12 p.m. The delay, this is in minutes, reaches higher than 35. So we see that's a really long time to wait for people who are going around lunchtime, 35 minutes. And on the 401 eastbound Kingston Road to Salem, we see that, well, again, around 12 p.m. it almost reaches 30 minutes. So this makes the returning commute much slower than it should be, and we want to avoid that extra 30 minutes that has to be added.
So now we also have some statistics on some less used roads, namely the free-flowing roads, and these roads usually get less traffic. And some of the examples are the 400 highway and the 407. So let's look at the 400 highway first, and we've noticed a very interesting statistic, which is that throughout the day, the 400 highway is always 2 minutes faster than it's expected. And we can see that on the upper lane of the 400 highway, there's absolutely no cars traveling. So this, according to the formula that we've discussed in the previous days, this road is not fully utilized, and it has a great potential to solve the congestion problem. And another highway that we'll also talk about in the later on slides is the 407 highway, and we can see from the statistics that it's generally 3 minutes faster than average, and throughout the day it is always faster than average. And also from the satellite image we can see there are few cars on it, and and we should fully utilize the road somehow to solve our congestion problem.
Okay, so here are the observations that we as a group found out while we were working on this project. We found out that while other roads were getting congested around certain areas, certain times of the day, the 407 express toll routes stayed very fast for the entirety because there are no signs of congestion on there, and it's completely free flow. And I believe, as a group, that 407, the express toll route, is a waste of resources because not many people are going on there. And to make the best of the resources we already have, we need to have people move onto these unused highways because we don't want these resources to go to waste now, do we? This way, it would even out the travel times of each highway. And yeah. But however, the main obstacle is that there is a toll route to Highway 407, thus giving the name Express Toll Route. Okay, this is our problem. Highway 407 is a highway that requires a toll for drivers to commute, and highways with toll fees free flow traffic because they are less used. And here in bold, this is the main problem. People do not want to pay for the 407 because it is kind of expensive, even if it has a much faster commute time. So our resolution to achieve the goal is to reduce the price of the ETR for 407, and we believe that it would allow more people to use the 407 because of the reduced toll price, and that way the resources would be used up more better because since 407 isn't really used that much, we can now get more people to use it. And also, it makes the overall traffic more balanced. So since 407 is now cheaper, we can have people from 401, which is a really congested highway, to move onto a highway that has free flow traffic, such as 407, where there are no signs of congestion and it's completely free flow. Okay, why we decide to reprice the highway, the toll price for Highway 407. Ontario, since 407 is owned by Ontario, I don't think Ontario is making full use of the expressway to maximize benefits. And by benefits, I mean for people to meet their demands, such as social needs, economic needs, like people going to jobs, meeting families, and etc. With a revised toll price, we think that people will use the 407 more frequently, reducing congestion that is occurring on other highways such as Highway 401 or Highway 400. And lastly, the highway will require more jobs for maintenance, and people will begin to build businesses along the 407. I think you guys seen this before, but on the sides of, or on the exits of each highway, you can see some tiny plazas, such as restaurants, washrooms, stores. So that's what we mean by businesses. They will open along the sides of 407. And cloud computing can fix this because we can track the number of cars on different roads, adjust the price of the express toll highways accordingly. And for example, if there are too many cars taking freeways, the price of the 407 ETR we can make it flexible so it can meet so they can be lowered to welcome a portion of commuters to switch routes. So that way the congestion between 401 and 407 will be neutralized, as in 401 will have less congestion and 407 will have more drivers.
So you believe that if we implement these two things, we can better the infrastructure of Toronto, and some of this can even be applied in other cities?
And to conclude, what we think is we should even the demand. This way we have less congestion, which is good. Hooray!
Just to clarify, the 407 is privately owned. It's owned by investors, and they've already made like 1,000% profit on it. But let me ask you this: what if you put a toll on the 401, What
that
do you
has
think?
been a topic.
Based on what you've learned, how would putting a small, let's say $2-3 toll on the 401 during the afternoon peak, what would it change? What elements within your system would it change?
Well, $2 or $3 compared to the toll price of 407. That's relatively really small. And I don't think it would stop a few commuters to go on the 401.
What would happen specifically in technical terms based on what you've learned? What would it change? Would it change the supply?
People won't take the highways anymore.
Okay, so they will go to alternate routes.
Yeah, like arterial roads instead. Yeah.
So would that fix the problem?
No, that would.
Okay, what questions do you guys have?
So how does the data that your group analyzed and the data that your group analyzed kind of come together? How does it relate to each other?
We're both trying to balance out something. For example, they're trying to balance the congestion between weekdays and weekends, and we're trying to balance the congestion between highways.
So how do they affect each other? How does doing one change the other?
It all leads us to these solutions that are the event metering, the tolling, the smart devices, the applications. So all these solutions are intended to they will sort of be solving the problems, all these problems, and these two particularly.
Go ahead, bro.
You guys,
Be loud, bro.
yeah, you guys mentioned that in one of, I think it was the first group, that you guys wanted to maybe use social pressure to kind of split it up, as you said, so that some people would go to a job be on the roads at 8, some people would be in roads at 9, some people would be on the roads at 11, whatever. But that's a really big change for a lot of businesses, and both big and small. So how do you think you could put pressure on them to do that?
Well, really, we were just giving that as an option. We weren't saying that we were going to actually implement that because that's a social change. We want to adjust our systems and not make society change how they're living their life so that it adjusts to them. So that was just an option. Like, our main 2 points are what they were saying with the toll routes and with our idea of the smart app.
Yeah, about that smart app. How would it interact with the light, with the stoplight to get it to change? I wasn't clear on that.
So what would happen is it would take the GPS data from, say it's running on my phone right now. It would take my GPS data, and if I'm waiting at the stoplight, and say there's no car going in front of me in the intersection, it'll notice that, and it'll change the light, make it green. Because that would be made by the government. So they would have access to these kinds of things.
So you're saying the government would need to change every single stoplight to make it sure it could interact with this app? That'd be a lot of money.
Well, it will be the advanced transportation management system that is on top of all this. So all the data is received by this system, and the data from the sensors, the data from the apps, everything is merged together, and they decide what signal to turn on at a specific intersection. So it is the ATMS that stands on top of all this. It's not the app that actually controls the light.
So remember how in the ITS lab we heard about the traffic control system Marlin, which uses information from multiple traffic simulators together, and with artificial intelligence, the goal is minimizing the delay. So it's a matter of basically reprogramming the controller and overriding some of the actions in situations where you have demand not meeting whatever pre-timed cycles that it has. And now, for example, they're running a pilot for it in a city. Try that. There was a question there. Yeah. Okay, let's thank the group.